Yesterday we were talking about the law of sines, and today we're going to be talking about law of cosines. Yes, mathematics does have its law, and don't try breaking these laws. I don't want to have to send the math police after you guys. So we're going to talk about law of cosines. Okay, what is that exactly? Well, you can see I've got a non-right triangle drawn here. I have an altitude going from angle C down to side C that's splitting this up into two right triangles. Using Pythagorean theorem then, I can say that that altitude k, I've got k squared plus x squared is going to equal a squared. Okay, nothing magical going on there. The other right triangle that's listed there, if I apply Pythagorean theorem there, I also have k squared. But this time I'm going to have plus the quantity c minus x, quantity squared, and that's going to be equal to b squared. Okay, nothing really terribly magical going on at these particular equations that we just came up with. And I have them set up specifically this way because what I want to take a look here, I want to take a look at is what happens if I start to solve these for k squared. So I can subtract our c minus x squared from both sides for this particular equation. And then for the bottom equation, I'm going to work that one upwards. And if I solve that for k squared as well, I'm going to end up with k squared is equal to a squared minus x squared. Just a little bit of algebraic simplification going on here. All right, so if you take a look, I've got two equations here, distinctly different, but both of them are equal to k squared. So let's see what happens if we set both of these equal to each other, because I've got both equations equal to k squared, so I could say that b squared minus the quantity c minus x squared is equal to a squared minus x squared. Okay? Alright, so some of you guys are probably sitting there thinking, alright, so what? So we've got these things that are equal to each other. How is that really going to be helpful? Well, that's going to be helpful because as I have this particular equation here, I can solve this for one of my variables. And one of the variables I want to try to solve it for is b squared. So in order to do that, I do need to do a little bit of expansion of our quadratic. So I'm going to have b squared minus the quantity c squared minus 2c times x plus x squared. And that whole quantity is equal to a squared minus x squared. Okay, move everything in parentheses over to the right-hand side so that I've solved this equation for b squared. So I'm going to end up with b squared equals a squared minus x squared plus c squared minus 2cx plus x squared. Notice I can do a little bit of a simplification here, and the x squareds cancel out. So that when I'm all done here, what I have left over is b squared is equal to a squared plus c squared minus 2cx. Okay, if I remember back to then our original triangle here, b was one of the sides of our triangle, a was one of the sides of our triangle, so was c, but I've got this funky minus 2 times c times x. Well, x was a part of one of those right triangles that we created by dropping that altitude k. And I don't want to have that as a part of my final equation. That for a second here. This is what the original triangle was, so I need to take a look at, alright, what can I do to simplify or substitute something in for x? Well, I know that if I take a look at my original triangle here, my triangle ABC, I know that there is a relationship that involves the side x. I could say that the sine of angle B is equal to I'm sorry, not sine. We're dealing with law of cosines here, not sine. Erase that, get back on track. Cosine of B is equal to the adjacent side divided by the hypotenuse. Okay, a little bit of algebraic simplification here. If I multiply both sides by a, I'm going to end up with a times the cosine of b is equal to x. Wonderful. I have something now that I can substitute in for x. If I bring back our original equation here that we had just been working with, I've got b squared is equal to a squared plus c squared minus 2a ax. To cx. I'll get that right yet. So I can substitute in for x. I've got b squared is equal to a squared plus c squared minus 2. And then the the x portion, remember when we simplified that, that was equal to a times the cosine of b. So I'm going to write a times c times the cosine of b. I'll keep my variables in alphabetical order here. So there you have it. You have what is known as the law of cosines. This law of cosines here relates some of the angles in the non-right triangle into our side. So we've got quite a relationship going on here. Remember, this is a law. I don't want to catch you guys breaking the law. You guys have yourself a great day, and look for the next lesson, which is going to deal with vectors in the plane.